Let's dive right into this explainer. We all consume chocolate constantly. We absolutely love the stuff. But when you actually look at its bizarre, purely accidental origins, and then contrast that with the high-stakes genetic engineering that's threatening its future today, honestly, the story is pretty shocking. We're going to trace this really fascinating line from ancient, sticky, natural food history straight into a modern controversy that could literally alter the biological makeup of our global food sources forever. To the uninitiated, raw cacao beans actually look and feel, well, surprisingly unappetizing. I mean, if you were to crack open a cacao pod today without knowing what was inside, you definitely wouldn't find anything resembling a dark, rich chocolate bar. Instead, as people point out all the time when they see it for the first time, you find these pale, sticky, raw seeds that look uncomfortably close to raw chicken meat. It begs a pretty obvious question. Why on earth did someone even try to eat this centuries ago?
That reaction really hits the nail on the head. How did early humans ever figure out that these strange, slimy seeds could become the delicious chocolate we crave today? It highlights this massive gap between what nature provides and the ridiculously complex culinary process required to unlock it. The sheer unlikelihood of someone looking at a gooey, raw cacao seed and intuitively knowing, oh yeah, this needs a highly specific multi-day chemical breakdown to taste good, well, it suggests that the birth of chocolate was just a beautiful, completely accidental kind of magic.
Because here's the thing. While the edible flesh surrounding those seeds actually tastes surprisingly sweet and fruity, kind of like Jolly Ranchers, believe it or not, the beans themselves require a wildly counterintuitive transformation. Just imagine our ancestors cracking open a pod. They likely sucked that sweet, fruity pulp right off the seeds and then just spat the bitter, raw beans out onto the ground. And what happened to those discarded beans next is exactly what gave us the chocolate we know today.
Yep. Those discarded beans gave us chocolate, all thanks to a highly specific three-step fermentation process. This turns those raw, bitter beans into the very foundation of cocoa. Fermentation is absolutely essential for producing high-quality chocolate. It's the engine that drives all those complex flavors we love. Literally, if you don't do this right, you don't get chocolate, period.
The first phase involves meticulously separating the beans from their stalks, making sure the process is super clean with minimal stringiness left behind. But here is the real kicker. You have to resist the urge to wash them off. You must not rinse the beans. That sticky, sugary coating you'd naturally want to clean off, that is exactly what's needed to kickstart the chemical reactions that will eventually give us those rich chocolate notes.
Next up, you have to wrap those unwashed beans in trimmed, washed banana leaves. This creates the perfect microclimate to protect the beans from decay. It's not just about covering them up, you know. The banana leaves actually trap the heat and moisture while guarding against the bad bacteria that would cause them to rot. It's this incredibly delicate balance between breaking the bean down and just letting it totally spoil.
Finally, you have an anaerobic packing process where the beans are sealed tightly, absolutely no air allowed, for 3 straight days. This is the waiting game. By cutting off the oxygen, you force a very specific type of fermentation. If you open that bundle after 3 days, it's wild. You'll notice a massive change. The texture alters, a completely new aroma develops, and that signals the beans have successfully fermented and are ready to be dried and eventually roasted.
And here is a crucial detail. This entire sealed process has to be maintained at right around 50 degrees for optimal fermentation to occur. Temperature is literally everything here. Too cold, the fermentation stalls out. Too hot, you completely ruin the flavor profile. Hitting that exact sweet spot is what turns a bitter, raw seed into the complex foundation for cocoa.
Now, looking back historically, people used some truly bizarre DIY tricks to kickstart this process. We're talking adding extra fruit pulp, throwing in extra sugar, or even chewing a few beans and just spitting right into the batch. The saliva actually introduced specific enzymes that aggressively jump-started fermentation. Honestly, it makes you wonder about the very first person who accidentally left a pile of spat-out, saliva-covered beans wrapped in a leaf out in the hot sun, only to discover they'd created culinary gold.
But if we shift gears from that sticky, supernatural food history to the modern era, there's a massive contrast. We go from smallholder farmers relying on natural cross-pollination to giant corporations utilizing advanced tools like CRISPR for calculated genetic editing. For centuries, cocoa farmers just saved seeds from a good harvest and planted them the next season, letting nature do its thing. Today, we're looking at a totally different reality where corporate science is stepping in at the most foundational genetic level.
And that brings us to a major concern that's been gaining a lot of traction online, raising some really serious questions about the ethics and risks of corporate control over global food biology. This isn't just about one company making a different type of chocolate bar. Critics are out there asking, who gave a single corporation the authority to alter the DNA of a widely relied upon plant without widespread public consent? It's being framed as a really critical issue of seed and food sovereignty.
The sheer permanence of this issue really comes down to one number: 40. A single cocoa tree cross-pollinates for 40 years. That number is exactly why critics are being so vocal right now. We aren't talking about an annual crop like corn or soy where you harvest it and just start over from scratch. A single cocoa tree lives, breeds, and spreads its pollen into the surrounding environment for 4 straight decades.
So, once this edited pollen from commercial sources mixes with the seeds being saved by smallholders, there is absolutely no recall mechanism. You can't undo the biological change. Just think about that for a second. Smallholders in rural villages depend on planting seeds from neighboring trees. If the wind carries genetically edited pollen onto their farms, their indigenous seeds are changed forever. You just can't unring a genetic bell once it's out in the wild.
And what's wild is that this irreversible process is happening as the major producing regions are still grappling with establishing oversight. Ghana and Côte d'Ivoire grow the vast majority of the world's cocoa. You'd naturally assume that such a massive alteration to a global food supply would be tightly controlled, right? Well, the regulatory landscape in these two nations currently lacks robust frameworks to actually monitor or manage these genetic changes.
Critics are quick to point out that with Ghana exempting many of these edits from regulation and Côte d'Ivoire lacking active enforcement of their biosafety laws, the global supply of cocoa is undergoing permanent alteration without standard regulatory safety nets. The core concern here is that this lack of active oversight means the long-term natural gene pool is being altered without any clear framework for monitoring the consequences.
So it all leaves us with a pretty profound final thought. Is the bizarre, naturally wonderful process we started with destined to be permanently rewritten by irreversible corporate genetic engineering? We've gone from ancient farmers accidentally discovering how to ferment strange seeds in banana leaves to a future where the very DNA of those seeds is being rewritten in a lab, with absolutely no way to turn back. It really makes you look at your next chocolate bar just a little bit differently, doesn't it?
Ready to grow? Master the science. Subscribe now. Click to watch more.